Hello, welcome back to my recorded classes. Today we are discussing the topic section number 4.6 Solving Congruences. So this is the topic from the course Mathematics for IT. So we will start the topic section number 4.6 Solving Linear Congruences. So for example, what we are doing here is if you are getting a system of congruences. For example, we have a two linear congruences are there. So from this, how can we calculate the x value? What is the solution of that linear congruence? Okay, solution same. If you are getting three system, for example, x equal a1 mod m1 and x congruent to a2 mod m2 and x congruent to a3 mod m3. Okay, so this is three system, correct? So how can we find the solution of this system of congruences? So we need to study this one. So this is the idea we are studying here. Now this section we are concentrating only two congruent system. Okay, only two congruent system, two case only we are discussing here. So we will start that one, 4.6 solving congruences. So for solving congruence system, we are using Chinese remainder theorem. Okay, we are in short notation CRT. C means Chinese remainder theorem, CRT. So what is the Chinese remainder theorem is telling, and how can we find the solution by using Chinese remainder theorem? So you can see, let m1 and m2 be relatively prime positive integers. m1 number and m2 number are relatively prime. You know what is the meaning relatively prime? The GCD of m1 and m2 should be 1. That is the meaning relatively prime positive integers, and a1 a2 are arbitrary integers. Then the system, see here we have a 2 system here, x congruent to a1 mod m1 and x congruent to a2 mod m2. Okay, this a1 a2 number is giving in the question, m1 and m2 number is giving. So from this system of congruence we need to calculate our solution. What is the x value? What are the x values possible? Okay, now especially we are finding a unique solution. Okay, the first solution only, x has a unique solution modulo m equal to m1 multiply m2, where 0 less than or equal to x less than m. That means we are finding the solution in this interval. Okay, 0 less than or equal to the solution less than m number. M number means the mode number multiply m1 multiply m2. That is the meaning m number. So below m number and more than 0. Okay, what is that solution? This solution we need to calculate. What is that x number? Okay, only one solution, and all other solutions congruent modulo m to this solution, that also solution. We have many solution this system, but we are finding a unique solution with 0 less than or equal to x less than m. That means this interval, what is that solution? That positive solution we are calculating here. Okay, so this is the Chinese remainder theorem. Now I will tell you what are the steps we are doing in Chinese remainder theorem. For two equations only we are taking, or two congruences only we are taking, two congruent system. Okay, so we will see what are these steps here we are doing. Steps for solving system of linear congruences for two equations. Okay, only for two. 3 and above we are not discussing here, only we are studying two systems. How can we find the solution of these two system congruences? Okay, so x equal to how much? So first equation, x congruent to a1 mod m1, okay, and x congruent to a2 mod m2. Okay, these are the two linear congruences. Okay, now what we do, if you are getting a question, first you write what is our a1 number and what is our a2 number. Okay, what is our m1 number and m2 number. Okay, before starting the question, a1 number means here you are getting a1, here a2 number you are getting, and here m1 number we are getting, and here m2 number we are getting. Okay, correctly understand this one, this idea. Now first step, verify m1 and m2 are relatively prime. Okay, that means this number m1 number and m2 number should be relatively prime. What is the meaning of that one? That means we need to check the GCD of the number m1 and m2. It should be equal to 1. That is the meaning relatively prime. Okay. So if it is relatively prime only, we can find the x value. So first check this one should be equal to 1. So this is the first step in the Chinese remainder theorem. Now after that, what we do is calculate m number, compute m. M means m1 multiply m2, m1 number multiply m2 number. So in second step, calculate what is m number. Okay. Now in third step, after that, compute z1 and z2. Two numbers. First one is z1 and second one is z2. These two number we are calculating. Z1 means m divided by m1, m number divided by m1 number, and z2 means m divided by m2 number. Okay, you can calculate that by using calculator. This is the third step. After that, we are calculating in the fourth step two numbers. We are calling it as y1 number and y2 number. What is the meaning of y1 number and y2 number? You can see y1 means z1 inverse. Z1 just before we go to z1 number. So z1 inverse mod m1. Okay, z1. All are suffix y1. y1 equal z1 inverse mod m1. Okay, all are suffix 1. You can note like that. And y2 means all are suffix 2 here. Okay, y2 means z2 inverse multiply z2 inverse mod m2. Okay, this is the y2 number. So y1 number and y2 number we need to calculate. I will explain when we are doing question how we are doing these numbers: z1 value, z2 value, y1 value and y2 value. Okay, now once you go to these numbers, okay, now we are writing the fifth step. What is the solution? We are writing here x value, x equal, the solution equal. What is the rule for that one? X congruent to a1 z1 y1, a1 multiply z1 multiply y1. A1 means we are getting in the system of linear congruence. See the a1 number. Okay, a1 number multiply z1 number multiply y1 number plus a2 multiply z2 multiply y2 mod m number. M number means m1 multiply m2. So this is the solution of that linear system, congruent system, by using Chinese remainder theorem, where x is the smallest positive integer that is simultaneously a solution of each of the congruent system. Here we are finding only the unique solution, that is the first positive integer, smallest positive integer solution. Okay, positive integer solution. That means that solution is 0 less than or equal to x less than m. This solution only we are calculating. Okay, actually we have the congruent system having many solutions, but we are calculating only the unique solution in between the number 0 and m. What is that solution? That smallest positive integer solution we are calculating by using Chinese remainder theorem. So I hope you understood this procedure. Okay, just remember this procedure. Now we have some examples here for your understanding. For example, this one, x congruent to 1 mod 5, x congruent to 4 mod 7. Okay, so what is the question? Find the value of x. What is the solution? Satisfy both of the congruences, x congruent 1 mod 5 and x congruent 4 mod 7. So as I told you, this example you can see. First I will discuss one example. Later you can check these examples, solved examples already here. So what I told, first you need to write a1 number, a2 value, m1 value and m2 value from this system. Okay, I will just give outline here. Then we will do one question. So this is the a1 number, this number 1. This is the a2 number, number 4. And this is the m1 number, number 5. And this is the m2 number, number 7. Okay, mode numbers are m1 and m2, and behind 1 and 4 are a1 and a2. Now first what you do is GCD of m1 and m2 should be 1. This is first we need to check. Okay, so first check this should be 1. Once you check this one, write the linear combination that we studied in last section 4.5. You remember how to write the linear combination. So from the linear combination, after that we calculate what is the z1 value, z2 value, y1 value and y2 value. I will explain when we are doing question how can we calculate that easily. Okay, so z1, z2, y1, y2. Once we calculated these numbers, we will go to the solution. In step 4, x equal to x congruent to a1 z1 y1 plus a2 z2 y2 mod m. Then once you simplified, you will get what is the solution you are getting. X equal to 11 mod 35, correct? So x equal to 11 is the solution of that system of congruence equations. Now see, this is the Chinese remainder theorem. Now same question we can do by using a shortcut method like this, okay, but we are not using this shortcut, okay, especially when we are doing questions. So shortcut method, you can check the answer correct or not, okay, only for that one. The shortcut method is only for checking your answer correct or not. For example, in this question, see, the first equation is x congruent to 1 mod 5. Second one is x congruent to 4 mod 7, correct? X congruent to 1 mod 5 and x congruent to 4 mod 7. These are the two equations. So from this, okay, you remember before section 4.3 section we are studied, x congruent to 1 mod 5 means what are the numbers we can choose x starting from this number, correct? X congruent to 1 mod 5, okay. So what we do, starting from this number, this is number 1, first we are writing, then 1 plus 5, this number, 1 plus 5 means 6, next number, then 6 plus 5 again, so 11, 11 plus 5, 16, like that going, okay. So start from this number, number 1, you remember 4.3 this idea, then next number, 1 plus the mode number 5, 6, then what is the next number, 6 plus the mode number, 6 plus 5, 11, like that it is continuing, okay. So that is writing here, and same like second equation also, same we are writing, okay, same we are writing, starting with the number 4, 4 plus 7, then that is 11, 11 plus 7, 18, like that it is going. Now out of these two numbers, check what is the common number, starting number or minimum common number, okay, minimum number, okay. So smallest positive integer, that is 11, that is the solution. So you can check your answer correct or not by using two steps. This is only for 2 by 2 system, keep in your mind. So this shortcut you can use only for checking your answer correct or not, okay, like this. But when we are doing question, we need to do by using like this, by using Chinese remainder theorem, okay. This is only for checking the answer, keep in your mind, only for checking the answer, okay. Especially when we are doing in examination descriptive question, okay, don't use the shortcut method, only use the Chinese remainder theorem as we discussed before. Okay, now here another example also you can do like this, like you can check your answer using this example also, solved example. You can see how to calculate the solution. You can later you can discuss this one, okay, and shortcut also for checking answer I wrote here. Okay, now let's start with some questions, okay, for understanding. Let's start some question. Exercise 4.6. Exercise 4.6. Solve the simultaneous congruence equations by using Chinese remainder theorem. Okay, solve. Solve means we need to find what is the x number, okay. So by using Chinese remainder theorem, x congruent to 2 mod 4, x congruent to 5 mod 9, okay. So this is the question. So we will do this question. So first one, x congruent to 2 mod 4, okay, and second one is x congruent to 5 mod 9, correct. These are the two congruence equations. Now I told you beginning, write the number, what is a1, what is a2, what is m1 and what is m2, these four numbers, correct. So this number, okay, whatever the number here, this is a1, this number is a2, and here the number is m1, and this number is m2 number, okay. So what is a1 number? A1 number is 2, a2 number is 5, m1 number is 4, and m2 number is 9, okay. So first we are writing these four numbers. Now after that we need to check, what we need to check, these two number, m1 number and m2 number should be relatively prime, okay. So we need to calculate the GCD of these two number, that is the first step we are doing, okay. So we will do here M1 number is, we got 4 and M2 is 9. M1 number is 4 and M2 number is 9. So first we are checking the GCD of these two number. So as we discussed before sections, I am just dividing our page into three parts like this. Now 4 and 9, out of these two number, 9 is the bigger number. Okay, so what we do, bigger number divided by small number, 9 divided by 4. Okay, very careful these steps what we are doing. So 9 divided by 4, you can check by calculator, you will get 2.25, correct, 2.25. Now just write what is the quotient and what is the remainder, because we are calculating GCD. Okay, so what is the quotient? Quotient number is 2, because here 2 point, correct, so 2 we are writing. Now remainder number means this number opposite of the quotient, 2 opposite is minus 2, multiply the divisor number, that is 4, correct. So you can check what is the number getting, minus 2, subtract first, then multiply 4, you will get answer equal to 1, remainder equal to 1. So by using division algorithm, how can we write? Bigger number is 9 equal quotient is 2, multiply divisor is 4 plus the remainder is 1, correct, plus the remainder is 1. Now again we are continuing with this number, 4 number and 1 number. All of you remember last section, same idea. So 4 is the bigger number divided by small number, 4 divided by 1, that is 4. 4 means 4.0, there is no point part. So quotient you are getting number 4 and remainder you are getting equal to 0, because there is no decimal. So remainder equal to 0. So how can we write that equation here? That means 4 equals 4 times divisor is 1 plus remainder is 0, correct. Now once you go to 0 number, we will stop here. Once you go to 0 number, we can stop. Now we can write what is the GCD. GCD of the number M1 and M2, correct. M1 means number 4, M2 is number 9. So GCD of these two number, what we studied by using Euclidean algorithm, last non-zero remainder. What is the remainder last other than 0? 1, correct. So GCD is getting 1. So we can say, what we can say, M1 and M2 are relatively prime number, correct. So GCD 1 means what we can say, solution exists, correct, solution exists. Okay, relatively prime, solution exists, that means we can find the x number, that is the meaning, solution exists. So I hope you understood the first step what we did, GCD, just to find the GCD of two number. Now just write this step in reverse order. Here only one step, 0 step we are not writing, only above steps, only one step only. From that you can write 1 equal to, you remember last section writing linear combination. So 1 equal 2 multiply 4, take to the left side. So 9 minus 2 multiply 4, correct. 1 equal 9 minus 2 multiply 4. There is no further simplification because only one step. So we can write 1 equals 9 means only one number. 9 means what we can write, 1 multiply 9, correct, minus 2 multiply 4 here. Okay. So all of you remember these steps. This is the linear combination step. Okay. Linear combination. Okay. So this step. Okay. So second step also we finished. Okay. Writing the linear combination. Now we are going to the third step now. So what are the numbers we need to calculate in the next step? We need to calculate Z1 and Z2 number, correct. So what was that Z1? Z1 equal, before calculating Z1, sorry, we need to calculate M number. M equal to, what is the value M? M equal M1 multiply M2. M1 multiply M2. What is M1 here? M1 means 4. Multiply, what is M2 here? 9. So 4 multiply 9, correct. So that is the M number, 36. M equal to 36. So first step we find the GCD. After we write linear combination. Now the second step we write what is the M number. M number equal to 36. Now we are going to calculate next to two number, Z1 number we need to calculate, and we need to calculate what is Z2 number, correct? Z1 number, what was the rule? M divided by M1, correct? M divided by M1. What is Z2? M divided by M2, okay? So we can check it, what is this number, okay? Equals, M number just now we got 36. So 36 divided by M1 number, how much it was? M1 number is 4, correct? So divided by 4, how much we are getting? 9, correct? So Z1 number is 9. Now Z2 number means M number 36 divided by M2 number. What is M2 here? 9. So 36 divided by 9. So we will get equal to 4. So we got M1 number and M2 number here. So I hope you understood the next step also. Okay, now we are going to find the next two number. What are the next two number? We need to calculate what is Y1 and what is Y2. Okay, Y1 and Y2. What is Y1? Z1 inverse mod M1. Okay, and what is Y2? Z2 inverse mod M2. Okay, little steps are there, but the question is easy. Okay, so we need to calculate what is these two number now, Y1 and Y2 number. Okay, so Z1 inverse. What is Z1 actually? Z1 is 9. Just before we got 9 inverse mod M1. What is M1? M1 is 4, correct? 9 inverse mod 4. And what is Z2 inverse? 4. Z is 4. So 4 inverse mod M2 means what is the number? 9, correct? 4 inverse mod 9. Now how to calculate this number? 9 inverse, okay? Concentrate here. 9 inverse. How to calculate this 9 inverse? For that we just see the linear combination step. What is the linear combination step? 1 equals 1 multiply 9 minus 2 multiply 4. This step, linear combination step, okay? I will write here and I will tell you. 1 equals 1 multiply 9 minus 2 multiply 4. This was the linear combination step, correct? Now if you want 9 inverse, okay, students carefully see, 9 inverse if you want, see this number 9, here is the 9, just to check what is the behind the number of 9, okay, that is the 9 inverse, okay, just behind the number of 9, this number, okay, that means what is the number getting? 1. 1 is a positive number, so no problem, no need to write mod 4, okay, 1 mod 4, okay, that means 1, we can write 1. If it is more than the number 4 only, we need to take that mode, otherwise the same number, okay, 1 number. So Y1 number we calculated, it is equal to 1. Now same way, Y2 number, what we are writing Y2 number? Y2 number means 4 inverse, see 4 inverse, 4 inverse means what I told, just to see the 4 number here, see this is the 4 number here, 4 number behind number, what is the behind number of 4 here? Minus 2, correct? So we can write Y2 means minus 2, here the number is negative, so we need to take the mod 9, minus 2 mod 9. I hope you understood how we are writing that Y1 and Y2 number, minus 2 mod 9. Now minus number we need to change, so what we will do, this minus 2 number add with 9, this is the short idea, minus 2 plus 9, what is minus 2 plus 9? 7, correct? Equal to 7. This is the Y2 value. Y2 equal to 7. So I hope you understood how to calculate the Y1 value and Y2 value. Okay. So this number, careful, this is the 9 inverse value and this is the 4 inverse value. Okay. So we go to Y1 number, we go to Y2 number, Z1 number and Z2 number. Now all the number we got. Now we are going to find the solution, last step. Okay. So now the solution is, what was the rule in Chinese remainder theorem? X congruent to A1 Z1 Y1 plus A2 Z2 Y2, okay, mod M number. Okay, you remember this rule I explained in this step by step here. Okay, this step, the same idea we are using. See, A1 Z1 Y1 plus A2 Z2 Y2 mod M. This is the solution, X congruent to. Okay, so we are going to calculate here mod m. Okay, so x congruent to, that means x congruent to a1 number. How much we got a1 number? A1 number in the beginning we wrote a1 number is 2. Okay, so 2 multiply. Okay, so we can write here 2 multiply z1 just before we got 9, correct, multiply y1 also here we got 1 plus, now a2 number we got 5, correct, you remember here this is a2 number, that is 5, multiply y2 number, sorry z2 number 4 multiply y2 number 7, mod m number here we got just before 36. Okay, m number is 36. So we can write x congruent to, now we can check this number in our calculator, 2 multiply 9 multiply 1. Okay, better when you are doing in calculator use the bracket. Okay, plus the second one 5 multiply 4 multiply 7, keep in one bracket, you will get 158 mod 36. Okay, 158 mod 36, that means this one you can enter your calculator, this one put it in a bracket, this one also put it in a bracket. Now 158 mod 36. Okay, how can we calculate 158 mod 36? Mod means, what is the meaning mod? Mod means the remainder value, correct, remainder value. So what you do, 158 divided by 36, you can check the calculator, 158 divided by 36, we studied in 4.2 section this idea, correct. So 158 divided by 36 means you are getting calculator 4.3888 like this. Okay, so what is the quotient? Quotient equal to 4. Find what is the remainder. Remainder equal to, what you do, opposite of the quotient, so minus 4, multiply the divisor number, correct. What is the divisor number? 36. Okay, so subtract 4, after that multiply 36, you will get equal to 14. This number is the answer. Okay, remainder, so x equal to 14 is the solution. X equal to 14 is the solution, or x congruent to 14 mod 36 is the solution. Always keep in our mind, we are writing the smallest positive solution, that means the solution in between 0 less than or equal to x less than m number. Here m number is 36, this number m number is 36, so 0 to 36, in between 0 and 36, what is the solution we are writing? So x equal to 14 is the solution. I hope you understood this question how to do, okay, by using Chinese remainder theorem. Now the same question we are using shortcut method, how to find the solution by shortcut method, that is only for checking your answer correct or not. Okay, we cannot do in exams, this is only for checking your answer correct or not, so we will do that one. X congruent to 2 mod 4 first. Okay, x congruent to 2 mod 4, this was the first one. Okay, and same way the second equation was x congruent to 5 mod 9. Okay, x congruent to 5 mod 9. Okay, so how to find the solution? By using shortcut, only for checking your answer correct or not. Okay, so by using shortcut method. Okay, so from the first linear congruence, okay, what are the numbers we can choose? Start from this number 2, comma, then 2 plus 4, add this number 2 plus 4, that is 6, then 6 plus 4, mode number only, 6 plus 4 10, 10 plus 4 14, 14 plus 4 18, like this going. Okay, you can write some numbers. Now from the second one, okay, what are the numbers we are writing? This number first 5, then 5 plus 9, 5 plus 9 means 14, 14 again add with the mode number, 14 plus 9 23, 23 plus 9, like this continuing. Now select the common one. Select the common one. See, 2 is not common, 6 not common, 14 is common here. Both, correct? So this is the minimum. Okay, minimum. 14 is the common and it should be the positive minimum. So we can write the answer. Solution is x equal to 14 mod m. Okay, so this is the shortcut way to find the answer fastly in 2 steps, but this is only for 2 by 2 system. Okay, so you can check your answer correct or not like this. Okay, now we will go to the next question. Solve the simultaneous congruence equation by using Chinese remainder theorem. X congruent to 2 mod 5, x congruent to 3 mod 7. So first we are writing what is your a1 and a2 and m1 number and m2 number, correct? So what is our a1? 2. a2 number 3. Mod 5 is m1. Mod 7 is m2. Okay, so write these 4 number first. Now check these 2 number GCD. Next step, GCD of these 2 number. Okay, GCD of 5 and 7 is how much? That is we are doing. So m1 number 5 and m2 equal to 7. Okay, so as we discussed, we are dividing like this. Now out of these 2 number, m2, 7 is the bigger number. Okay, so bigger number 7 divided by small number 5, correct? 7 divided by 5, you can check the calculator, what is this number? 1.4. So what will be the q? Q means 1 and r we need to calculate remainder number. So what we do, opposite of the quotient, 1 opposite minus 1, multiply the divisor number 5, correct? So subtract 1, multiply 5, so that you are getting remainder equal to 2. Okay, remainder equal to 2. So we got remainder number equal to 2 here. Now, so first step, how can we write? Bigger number 7 equals quotient number is 1 multiply divisor number is 5 plus the remainder number is 2, correct? Now again we are taking the number 5 and 2. So 5 divided by 2, correct? 5 divided by 2 we will get equal to 2.5. So what will be the quotient? Quotient number equal to 2 and remainder number equals, subtract the quotient opposite is minus 2. So minus 2 multiply divisor is 2, correct? So we will get the remainder number here. So 1 we are getting. Okay, so what we can write? 5 equals 2 times divisor is 2 plus 1. Now the third one again, 2 and 1. 2 divided by 1 means 2. 2 means 2.0, correct? So quotient equal to 2 and remainder equal to 0 because there is no fraction. So remainder equal to 0 here. So we can write 2 equals 2 multiply 1 plus 0. Okay, so once you go to 0 number, we need to stop here. Once you go to 0, we need to stop there, correct? Now what is the GCD we are writing? GCD of the number m1 and m2. GCD of m1 and m2 equal last non-zero remainder, it is 1. So it is relatively prime. Relatively prime means solution exists. Okay, relatively prime, so solution exists. Okay, now we will go to the reverse order linear combination. So first we are writing this step, 1 equals 5 minus 2 multiply 2, correct? We need to take this on the next side. Now from the top one here, we need to write what is 2. 2 equals 7 minus 1 multiply 5. We need to take this to the next side. So 7 minus 1 multiply 5 we are writing. Okay. Now we need to write the linear combination, because here we have two steps. Two steps are there. So starting from the one step here. So 1 equals, okay, 1 equal to 5 minus 2 multiply 2. 2 multiply 2. Last step it was only one step, so we got easily. 5 minus 2 multiply 2. Now we need to change this 2 number, correct? This 2 number we need to change, as we discussed in last section. Okay, so what we got equal to 5 minus 2 multiply 2 means 7 minus 1 multiply 5. Okay, now expand the bracket and simplify. We need to expand here 2 to 7 and 2 to here. So 5 first. 5 means, what is the meaning of 5? 1 multiply 5, correct? So 1 equal, only 5 means, meaning is 1 multiply 5. You remember last section, I hope. Now 2 multiply 7 minus 2 multiply 7 minus plus 2 multiply 1 2 multiply 5, correct, plus 2 multiply 5. I hope you understood. Now we need to add the same term. What are the same term? Here 1 multiply 5 is there, here plus 2 multiply 5 is there, correct? 1 multiply 5 plus 2 multiply 5, how much it will be? 5 we are writing same, 1 plus 2, that is 3 multiply 5. Okay, so equal to 1 equals 3 multiply 5 minus 2 multiply 7. Okay, 2 multiply 7. So just to note this step, this is the linear combination step. Okay, linear combination. Okay, so first step is over, just finding GCD and linear combination. Now we are going to the second step. We need to write what is m equal to, correct? What is m? m1 multiply m2. What is m1 here? As we discussed in the question, m1 is 5, m2 equal to 7. Okay, m1 equal to 5 and m2 equal to 7. So equal 35. Okay. Now once we calculated m number, we will go to z1 number and z2 number, correct? Now we are doing these four numbers, z1, z2, after that y1 and y2. Okay, so carefully you can do by using calculator. First z1 means m divided by m1. What is m? M means 35 divided by what is m1? 5. So how much we are getting? 7. Correct? z1 equal to 7. Now z2, m divided by m2. What is m? 35. What is m2? 7. So how much we are getting? 5. z2 equal to 5 here. Okay. Now we are going to calculate y1 and y2. What is y1? Y1 means z1 inverse mod m1, and y2 means z2 inverse mod m2. Okay, so we will calculate first z1 inverse. z1 means 7 inverse mod m1. What is m1? 5. Okay, and here z2 means 5, so 5 inverse, z2 inverse. Okay, z2 inverse mod m2 means 7. Okay, you can do slowly, write and do step by steps. So we will get like this. Now calculate what is this number, these two number. Okay, we need to calculate what is 7 inverse. Okay, you can see the linear combination step. 7. See, this is the 7 behind the number. This is the 7 inverse, minus 2. Okay, so minus 2 mod 5, because number is minus, so we need to take mod 5. Minus 2 mod 5 means what is the number? As I told you, add minus 2 plus 5, correct? So what will be the number? Minus 2 plus 5 means 3. Okay, so y1 number is 3. I hope you understood how to calculate y1 number. Now we will go to the y2 number now. y2 means 5 inverse. 5 inverse means 5 in linear combination, 5 behind number. Okay, that is 3. So we can write here 3 mod 7. No need to take mod because 3 is the number, positive number, and smaller than 7 also. So 3 is the number. y2 equal to 3. So y1 3, y2 also we go to 3. So we got all the numbers now. Okay, now we are writing the solution. Solution is x congruent to a1 multiply z1 multiply y1 plus a2 multiply z2 multiply y2 mod m number, correct, equal, that means x congruent to, what is a1 number? First we wrote a1 is 2, a2 equal to 3, correct? a1 equal to 2 multiply z1, just before we got 7, y1 is 3, so 7 multiply 3 plus a2 number is, as I told you, 3 multiply z2 multiply y2, z2 is 5, y2 means 3, 5 multiply 3, 5 multiply 3 mod m number 35. You remember here we have m equal to 35. Now you can use the calculator. So x congruent to, check this number. So as I told you, when you are entering calculator, this one put it in a bracket, put in a bracket. Okay, so x congruent to, so check this one, 2 multiply 7 multiply 3 plus 3 multiply 5 multiply 3, we will get 87. 87 mod 35. Okay, now as I told you how to calculate that mod number. Mod number means we need to calculate the remainder. So just 87 divided by 35 we can do. Okay, you can check by calculator what is 87 divided by 35, that means 2.485, like this going. Okay, so what will be the quotient? Quotient equal to 2. What will be the remainder? That number opposite of the quotient, minus 2. Multiply the remainder, divisor number 35. Multiply 35, correct? So subtract the number 2, multiply 35. Okay, so first we are doing 87 divided by 35, already there in your calculator, you know, 2.48. From that subtract the number 2, after that multiply the number 35, you will get 17. So that is the answer. So x equals, or x congruent to 17 mod 35. So x equal to 17 otherwise. Okay, that is the solution. And make sure this number, positive number only we are writing, 0 less than or equal to x less than m number. What is the m number? 35. So the answer 0 to 35 in between. So it is correct, 17. So this is the second question. I hope you understood. Now this answer correct or not, you can use by shortcut method. See, I will do here the shortcut. Okay, the shortcut method. This is only for checking the answer. Okay, so first x congruent to mod 5. Second one, x congruent to 3 mod 7. So from these, what are the numbers? We can get it 2, then 2 plus 5 7, 7 plus 5 12, 12 plus 5 17, like this going. Now here 3, first number, 3 plus 7 10, 10 plus 7, 17, like this going. Select the common number. Common number is 17 only, and that is the smallest one. So answer is x equal to 17. Solution. Okay. So when we are preparing exam mode, okay, don't do like this. This is only for checking your answer. Only for 2 by 2 this one. This is shortcut. Only for checking, okay. Answer. Okay. I hope you understood this question, Chinese remainder theorem, these steps. One more question we will do. Okay. Solve the simultaneous congruence equation by Chinese remainder theorem. This is question number 3. Okay. So here we are starting. So what are the A number here? A1 number 4, A2 number 5, M1 number 7, M2 number 9. Correct? So first we are going to find the GCD of these two numbers, M1 and M2. So here 9 is the bigger number. Okay. So I am dividing here 3 like this. So first bigger number 9 divided by small number 7. 9 divided by 7. What answer? 1.285 like this. Okay, you can practice with me. So quotient equal to 1. Remainder you can check. From here subtract 1. After that multiply 7. You will get it 2. So first one, bigger number is 9, quotient is 1, divisor is 7, plus remainder number is 2. Okay. Now take 7 and 2. So 7 divided by 2 equals, okay, 7 divided by 2 means 3.5. So quotient equal to 3. Check what is the remainder value. What we need to do? Subtract 3. Opposite of the quotient is minus 3. Multiply divisor number is 2. Correct? You will get 1. So we can write 7 equals 3 multiply 2 plus 1. Now 2 and 1. 2 divided by 1, it is 2. 2 means 2.0. So quotient equal to 2 and remainder equal to 0 because there is no fraction. So we can write 2 equals 2 times 1 plus 0. So once you go to 0, we can stop. Write the GCD of two number. GCD of the number M1 and M2 equals last non-zero remainder. So what is the last non-zero remainder? 1. So GCD is 1. That means that two numbers are relatively prime. So solution exists. Solution exists. Always it should be 1. Keep in your mind. Now write in reverse order this step first. 1 equals 7 minus 3 multiply 2. Now you are familiarized with these steps because all the question we are doing the steps linear combination. Now here 2 number. So 2 equals 9 minus 1 multiply 7. This 1 multiply 7 we are taking next side. 1 multiply 7. Now write the linear combination. For that, starting from this step, 1 equals. So we can write 1 equals 7 minus 3 multiply 2. Correct? Now we need to change this number 2. Yes, because here number 2. What is number 2? 9 minus 1 multiply 7. So 7 minus 3, use this bracket, 9 minus 1 multiply 7. Okay, I hope you got it, this step. Okay, 9 minus 1 multiply 7. Now expand the bracket. Okay, 3 expand here, expand here. So what we can write, equals, only 7 means 1 multiply 7 minus 3 multiply 9 minus minus plus 3 multiply 1 is 3, 7 same. Okay, now we can add here 1 multiply 7 and plus 3 multiply 7, these two. So 1 multiply 7 plus 3 multiply 7. 7 only one time writing, 1 plus 3 means 4. 4 multiply 7. So we can write this step 1 equals, okay, 4 multiply 7 minus 3 multiply 9. Just note this step. This is the linear combination step. Okay, now we will go to the number calculations. We need to find that 4 numbers. First we need to do Z1 number, sorry, before that M number, then Z1 number, then Z2 number, correct? After that Y1 number, Y2 number. Okay, first M number. What is M number? M1 multiply M2, correct? What is M1 and M2? Equals, you can see M1 number is 7, M2 number is 9. 7 multiply 9. Okay, 7 multiply 9. That means equal to 63. Okay, now Z1 number means what we do? M number divided by M1 number. M number means 63 divided by M1 means 7. So 63 divided by 7, that is 9. Now Z2 means M divided by M2 number. What is M? 63 divided by what is M2? 9. So how many times? 7. So Z1, Z2 we got. Now we are going to calculate what is Y1 and Y2. Y1 means Z1 inverse mod M1. Y2 means Z2 inverse mod M2. What is Z1? Just before we wrote, Z1 means 9. Z1 inverse, so 9 inverse mod M1 means 7. What is Z2? Z2 means 7. So Z2 inverse means 7 inverse. Mod M2 means 9. Now check this number from the linear combination. What are the answers? 9 inverse. So 9 is here. So what is the behind number of 9? Minus 3. See here, minus 3. So minus 3 mod 7. Okay, minus 3 mod 7. So what I told, just add the number minus 3 and 4. Sorry, 7. Minus 3 add with 7. I hope you understood. Minus 3 plus 7. We did many questions, so you will get 4. This is the Y1. Now 7 inverse, same way you can check what is 7 inverse. 7 here, 7 inverse, 7 behind number 4. So 4 positive number, no problem. 4 mod 9, below 9 also. So we will get Y2 equals same number 4. Okay, so we got M, Z1, Z2, Y1 and Y2. Now we are writing the solution. Okay, so solution is X congruent to A1 Z1 Y1 plus A2 Z2 Y2 mod M number. That means x congruent to A1. You can check what is A1. A1 is 4. So 4 multiply Z1 means 9, Y1 means 4. So 9 multiply 4. Plus A2 means 5. Okay, remember in the beginning A2 equal to 5 here. So 5 multiply Z2, Y2. Z2 is 7, Y2 is 4. So 7 multiply 4. 7 multiply 4 mod M number. What is M number here? 63, correct? 63. So we can check 4 multiply 9 multiply 4 plus 5 multiply 7 multiply 4. Okay, we will get x congruent to 284 mod 63. Now just to find what is this mode. Mode means we need to calculate the remainder, correct? So 284 divided by 63. Check this number. 284 divided by 63 is 4.507 like it is going. So quotient equal to 4. Remainder means we need to subtract 4, opposite of the quotient, minus 4. Multiply 63, correct? You will get 32. So what will be the answer? X equals 32 because it is below 63. So it is correct because 0 less than or equal to x less than m number. M number is 63. So below 63 our answer. 32. So 32 is the solution. So I hope you understood this question also. Now this question also I am using the shortcut method just to check the answer correct or not by using shortcut method. So first equation we can write, second equation, congruence equation we can write. First one 4 mod 7. 4 mod 7. Second one 5 mod 9. So here what are the numbers we can write, we can check it. So start with 4, then 4 plus 7, 11, correct? Now 11 plus 7, that is 18. Now 18 plus 7, 25. 25 plus 7, that is 32. Like that it is going. Now second one, 5 plus 9, that means 14, first number. Then 14 plus the mod number 9 again, 23. Then 23 plus 9, 32. Like this continuing. Now select what is the common number here. Okay, common number is 32. Out of the common number, which is the minimum, smallest one, that is the answer. So x equal to 32 is the solution. Okay, the positive solution. This is the shortcut idea, the same question. So this also just careful, shortcut method only for checking the answer. Okay, so I hope you understood the idea. Chinese remainder theorem, what we discussed. Chinese remainder theorem, CRT. So what are the steps we did in the Chinese remainder theorem? First we write A1 number, A2 number, M1 number and M2 number. Okay, just to revise the idea what we did in the first step. This is the first step we did. A1, A2, M1, M2. Then what we do after, this is not a step, you can write in the beginning. Now first step what we do, just to check the GCD of the number, M1 and M2 number, correct, should be 1. This is the first step. After that, from here itself we are written the linear combination, correct, linear combination. These two are the main step. Write the linear combination and GCD check it should be 1 or not. So this is the first step we did, linear combination and GCD number. Now after that, what is the next step we did? Step number 2, we are calculated the M number. M means M1 multiply M2, correct? We are calculated. Now the third steps. Okay, now we did the third step, step number 3. What we did? Calculate Z1 number, M divided by M1, and comma Z2 number, M divided by M2. Correct? This is the third step we did. Okay, I am just writing in order. Okay, totally what we did in the question. Now after we did the fourth step, calculated y1. Y1 means Z1 inverse mod M1, and y2 means Z2 inverse mod M2. Okay, so we calculated these two number, y1 and y2 number. Okay, now once you got all these numbers, lastly we write what is the solution in the fifth step. Correct? Solution is x congruent to a1 z1 y1 plus a2 z2 y2 mod m. Okay, mod m. So here we are getting what is the solution. Okay, so this is the Chinese remainder theorem in two equation, two system of two congruence equation case. Okay, so I hope you understood the idea how we did. Now you can check the examples what we shown in the beginning. That two examples you can check the steps. Okay, and you can verify by using calculator. And the shortcut method only used for checking the answer, but the procedure Chinese remainder theorem you need to do these steps 1, 2, 3, 4 and these 5 steps. Okay, so this video, okay, I explained the Chinese remainder theorem. I hope all of you understood. Thank you for watching. Please subscribe my channel for getting more videos, more recorded classes. Thank you very much.